Working on the bishop here, we are going to go ahead and do the fourth axis operations for this. I've created a drawing for it so that you'll be able to work off of it. This is the drawing. I'll put that into Canvas for you guys. So what I have is basically the exact same setup. Let me clear up a little bit of space or a little bit of mess on the screen. I've got my bishop sitting here, and what I've done is I went ahead and drew the fluting into it and then put this notch in here, which is slight design changes from the original bishop that we had from Titans of CNC. We're just changing around some things so that it fits our machines just a little bit better. So we've got this notch here, and then the fluting really is the exact same thing from the pawn. If you want to import that over, carry it on over from what you had before, that's totally fine to do. What I'm going to do is I'm going to start back with doing the fluting and then come in and bring in a 3/8 end mill and then do this edge over here. I'm going to take it just a little bit easy on this edge because we are starting to get out far away from the part. So I want to make sure that I don't kind of kickstand this part out. So again, the bishop and the pawn, neither one of them need any kind of orientation pin on the back side. Every part other than the bishop and the pawn will. So I've got one roughly started. I threw in just one just to make sure I was in the right orientation. So I'm going to go back into this one. So here is my fluting, and let's take just a few seconds to talk about what it is that we're using. I've got a 3/8 ball end mill. I've actually been playing with it just a little bit because since that area that we're cutting is a 3/8, you can't quite get the 3/8 in there. I just have it set at 350 right now. I can bring it up. If I go over to cutter, I can bring it up to probably 370, might be enough to do it. Leave everything else alone. Go back down to 2 flutes because that is a 2 flute tool. It is high speed, and the more information that you put here, the better everything is going to go. So let's just look through everything. Cutting data. I'm at 90 inches a minute. I give a feed per tooth of 7. I'll probably go down to 5 on that. My spindle RPM for this one is 6,000. Without doing the math, I think that that's pretty good. I'll do the math as we go just to make sure that that is it. But I think this is what I had set from previous, and it seems like that did pretty well for me. So it is set for tool 6. You can change it to whatever you want. Tool 1 is fine, and that's just a 3/8 ball end mill. We'll adapt everything to that. Go ahead and select that tool. So now I've got 6,000s for my RPM, or 6,000 for my RPM, 5,000s feet per tooth. That puts me at a lead in, lead out at 60 inches per minute. My ramp feed rate is 90. So yeah, I'm pretty happy with that for what we're doing. Now maybe on my finish pass, if I want to take a finish pass through there, I might do it a little bit different. This tool may need to be offset just a little bit. I'm not sure if 370 will fit in there or not. So I have my rotary axis selected, and then my origin just selected this back edge of the part. I can select my model or not. Not going to make much difference here. I want to come in and I want to hit my touch surfaces. I'm going to change this tolerance to 1,000. I have a face selected. I'm going to deselect that face and then go through and select all of the faces that I want to choose. So starting here, and that looks like it's in alignment with my flat. And I'll just go around here. I don't know that I necessarily have a preference in the rotation that it does. I want to make sure I get all 8 flats. And let's see, I want to go in a line. I don't want to leave any kind of offset. I don't really think that I want to leave any kind of stock on this one. I don't know that I'll need it. I am doing a full retract. I would not have to do that. I could do a minimum retract on this. I've got some lead in, lead out. I might change those radiuses around. I think I've done that before. Just a real small radius if I want to do that. I think I need some radius for that. I can have an extension on that if I want to. For me, I think I'm going to need to play with this. I'm not super familiar with some of the rotary stuff, so for me, I have to play with it just a little bit to see how I like it, and then I keep coming back and forth on some stuff. Let's see what that looks like. Okay, clearly I've got some problems with my lead in, lead out. I'm not doing what I need to be doing, so I need to jump back in there and figure out where my problems are at. So typically one of the first things that I'm going to do is I'm going to go back and figure out what I had and how that affects me. So let's just kind of bring back some of these numbers and let's see, let's do full retract on that. Still looks like it's giving me some problems here. So I got to try to figure out where my problems are at. So let's just say let's see what this 1,000 looks like. My problem could actually not be here, so let's go back and change this to 10, and let's go back to my tool. Let's do a quick edit on the radius of that. Let's change that back to 350. See if that has any effect on my part. All right, now I'm getting full length back. So my problem was in my radius of my tool, not allowing me to go all the way down. But my exit strategy and end strategy, depending on which one it is, looks good, except for some of them look really crazy. Some of them must be at that 1 inch. Yeah, so here I've got a lead out radius of 1 inch. Let's change that to 1,000. Let's change that to 1,000 as well. See what it looks like now. That looks more like it. So I can do a full retract. I can go back in minimum retract to see what that looks like. Probably not much difference for what we're working on. Slightly, it doesn't go up quite as high, clears the part, goes around, and so that looks pretty good. So I could run that graphically. I'll do a quick save. And then just go ahead and run the graphics for this. Rotate all the way around it. So I'm done with that. That I'm pretty happy with. That is going to be exactly like the pawn. So where ours changes on this setup is we need to come in here and mill this little step. And so what I'm going to do is I'm going to just come on down and I'm going to do a 2D contour. I'm just going to do this edge right here. I need to change tools. And we're kind of in 3/8 world, so maybe I'll just use this 3/8 flat end mill and I'll take a look at it on some specs just to see what I got. I will use a 2-flute end mill, and it is going to be a high-speed steel. And let's look at some cutting data. 600 surface feet per minute. I can do feet per tooth, not probably at 7, probably more like 4. As I get further out, I get less and less amounts of strength, so I change my feed per tooth down just a little bit. If I want to spin at that 6,000 again, I can come in here and either hit 600 surface feet per minute or 6,000 RPM. And so either way that I want to do that. So I can change my ramp spindle speed as well. Just make that 6,000 all the way around it. My cutting feed rate is going to be 36 inches per minute. My lead in, my lead out will be the same. My ramping will be higher, which is totally fine. Nothing else really has any kind of play into what we're doing. Go to post processor. We're going to go ahead and change that to tool 2. Let everything follow that. And we will accept that. Okay, and we'll select that as our tool. So we're just going to be doing tool 1 and tool 2. Come in, I select my contour that I want to cut. It's just going to be this line right there. And I'm not really worried too much about where that lands. It doesn't have really a critical tolerance, but I do want to be able to have some control on it. So I'll go ahead and hit where. That means I need to set my tool offset to 0 on my machine. And let's do a compensation radius of, let's see if I can get away with 5. Let's see, if I want to, I can, let's see, I can adjust a finished feed rate if I want. I can also kind of control that in my steps if I want to. And so I don't really want to do multiple depths, but maybe I want to do some roughing passes across it. So my maximum step over, let's say maybe I want to make my maximum step over not 10, but 100. It really shouldn't do a ton of steps as it goes across there. So let's shrink that up a little bit. No multiple depths, so I'll bring it all the way down to depth. I'll just step over a couple of times. And let's say I'll do it in, let's say 3 steps. Probably okay here. None of these things. Lead in, lead out might have a little bit of effect on it. Let's see if I can get away with doing a lead in and lead out and just move on past it. Nope. It's okay. So my radius is pretty small here. And then it's just gonna, the lead out's gonna follow the same. So I can do okay with that. I really don't need a radius for the lead, a vertical radius for the lead in. So here I'm gonna come in, I'm gonna do a couple of passes, and then my last pass is shorter. I've got this small radial lead in, small radial lead out, about 37 thousandths. So step, step, step. My first one may not even touch the part, or if it does, it just barely touches the part. But I can kind of work into that, because remember, it kind of starts to come out like a diving board out here. And so we don't want to have a big giant cut across here. I'm not really worried about it coming out, because I've got a big chunk of it in the vise. I am a little concerned about chatter on this side. So that would be the only time I think maybe I might come in and do some type of finish pass. I'll let you guys play around with that for yourself. So if I want to, let's do a quick save. And if I want to see simulation for that, run it semi-slow. And you might want to set your flat so it's at the 0 point, the 180 point, the 90 point, whatever you choose. That'll be totally fine and up to you. I don't know that I really care where mine is at. I don't care if it rotates to 90 degrees or even 45 degrees to do it. I just want to make sure that it gets on there. Okay, so let's do this. We'll do another quick setup. Everything should be good because I put those things in earlier. Program is 250. And so I might just do a comment that says Bishop. Milling. And the operations is just going to be set up 4 and 2 tools. Happy with all those things, and then enter. Take a look at my code. 3/8 ball and mill, tool 1, 90, got some rotations in there. Go down to the tool change, and it's going to 360, which would be the same as 0. It's going to rotate there, and then from that point on, it should take care of all of my step overs on that. Let's see. I'm just taking a look, looking for if I have any kind of compensation put in here. I'm not seeing I don't see a G41. If I do, it's probably gonna, there it is. G41 D2, so I do have some cutter compensation in there just so I can adjust that finish pass or adjust the tool if I need to, and that's good. So we got that by using wear in our offsets. I do have the standby tool picking up. I could take that out if I wanted to just by turning standby tool off. On this, I would want to make sure that it rotated to the designation of where I wanted, because I don't want that to be in a loose state. So by rotating back to 360 or 0, I'm in a good spot to keep clamp down and to do my milling for that. So other than that, I think that I'm marginally happy with the part. I'm still getting used to the rotary with fusion as well. So like areas like this, I'm not super happy with, but I'm kind of learning as I'm going. So you need to have that program ready to run for when we come back to class in Tuesday or on Tuesday. So all right, we will see you then.